Okay, hi everybody. Today we're going to cover limiting reactant calculations. I know this isn't as good as if I was actually in class. Try your best today, go through the slides and all that, and then when I get back, we will pick it up from there and kind of go over any questions that you have. So again, this is all going through the notes, so you have this exact slides and you have them in your note packet as well. So today we're going to cover limiting reactants. The limiting reactant is the reactant that runs out first and limits the amount of product we can make. So it's really just deciding what is the max amount we can make from our reactants. We'll have two mass calculations, so instead of just doing one like what we've been doing, we're actually going to have two mass-to-mass calculations. There may also be a couple of multi-step or multiple calculations as well. The limiting reactant is always the one that yields the smaller amount. So anytime we're looking for the limiting reactant, we look back, or we look at the final product. Whatever the smaller number is decides that is going to be our limiting reactant. So let's run through a real world example of making funfetti cupcakes. So when we make a funfetti cupcake, if you look on the side of the box, you need one mix, 3 eggs, 2 tablespoons of oil, and that makes 1 pan of cupcakes. So let's say in our kitchen we have 3 mixes, 15 eggs, and 8 tablespoons, and we want to know what is the max amount of cupcakes we can make. So the first thing we can do is you need to convert from mixes to pans of cupcakes. So for every 1 mix, and again all these numbers are coming from up here, these are just our ratios here. For every 1 mix we can make 1 pan of cupcakes. 3 times 1 divided by 1 is 3 pans. Then we have 15 eggs, so we would have our 3 eggs on the bottom with our 1 pan on top. 15 times 1 divided by 3 is 5. And then 8 tablespoons of oil, we would have our 2 tablespoons of oil on the bottom with our 1 pan on top. 8 times 1 divided by 2 equals 4. So now we need to see what would be the max amount we could make if we just had these ingredients. So if we had these 3 ingredients in this quantity, we would know we could only make 3 pans, because we're going to run out of mix first before we run out of anything else. So we would have leftover oil and eggs. So the mixes are considered our limiting reactant. That's the reactant that's going to run out of first, so it's going to stop how many pans of cupcakes we can make. Okay, let's go back to chemistry. So we have a problem like this. If 17.1 grams of potassium reacts with 14.3 grams of fluorine, which reactant is the limiting reactant, and what mass of potassium fluoride can theoretically be produced? Okay, so we see we have 2 numbers now in our problem. So we have 17.1 grams of potassium and 14.3 grams of fluorine. These are going to be our knowns for our problem. Our unknown is going to stay the same, which our unknown is what mass of potassium fluoride can theoretically be produced. So we want to know what is the mass, that's measured in grams, of potassium fluoride. So we have our word equation and our formula equation, and it's balanced. So we need to figure out how much can we make. So we start with our first known. Our first known is the first one we run into in the problem, so 17.1 grams of potassium. Our unknown is what the question is asking for, what mass of potassium fluoride. So it's going to be our U. So we always start with what we know, our 17.1 grams. Go from grams to moles. We've got that from the periodic table. We then go from moles of known, our 2 here, to moles of unknown. And then we go into our molar mass of potassium fluoride over here. So you get 58.10 grams. Plug that in up top. Multiply across the top, get your answer. Multiply across the bottom, get your answer. Divide your 2 answers to get your final answer of 25.4 grams. Again, 3 sig figs, 3 sig figs in your answer. So that's our first problem. So it's our first stoichiometry problem. Now I have another known. So I have to do it again so I can compare my 2 reactants to see what is my limiting. So I start with my other known, which is 14.3 grams of fluorine. Our unknown stays the same. So this is not going to change. So this will be the same for both problems. Start with what we know. our 14.3 grams. Convert fluorine or from grams to moles. And again, we look up fluorine, multiply that by 2 because of our subscript here to get 38. Switch from moles of known to unknown, and then plug in that 58.10 grams of potassium fluoride we found before. The helpful thing is when we're solving these problems, this section here is going to be the same on both problems. So once you solve it for one, you just have to plug it in down here at the bottom. So then we multiply across the top, get your answer, multiply across the bottom, get your answer, to then get your final answer, 43.7 grams. Okay, so we have our two theoretical yields here. So we always want to pick the smaller one because that's what we're going to run out of first. So that's telling us potassium, because that's our known here, is our limiting reactant. That's what we're going to run out of first, meaning we're going to have leftover or excess fluorine. It also says we can only make 24 or 25.4 grams of potassium fluoride possible. We are going to have leftover fluorine, that's okay, but when the question asks what is the limiting reactant and what is the mass that we can theoretically produce, we can theoretically produce 25.4 grams, and our limiting is potassium. So in a reaction, if I was given this amount of 17.1 grams of potassium and 14.3 grams of fluorine, I'm going to run out of potassium first. Okay, let's do another one. How many moles of iron 3 oxide can be produced from the reaction of 13.17 moles of iron with 18.19 moles of oxygen? So again, I have two knowns. I have 13.17 moles of iron, and I have 18.19 moles of oxygen. So those are going to be my two knowns in this problem. So we have our word equation, our formula equation, and balance it. Again, if you're still struggling in that, make sure you come see me so we can get this cleared up. Okay, so our first known is that 13.17 moles of iron. Our unknown is how many moles of iron oxide we have. So we start with what we know. We have 13.17 moles. Now, we're already in moles. That means we just need to convert from moles of known to unknown. This is just a mole-to-mole problem. So I have my 2 moles of iron oxide. I have my 4 moles of iron on the bottom. 13.17 times 2 equals, divided by 4, and you get 6.585 moles of iron 3 oxide. And again, 4 sig figs here, 4 sig figs here. Okay, our other known is at 18.19 moles of oxygen. With our unknown, again, the exact same as before. So we're going to start with what we know, and then we're going to switch from moles of known to unknown. So we're going to have our 3 moles of oxygen on the bottom, our 2 moles of iron oxide. Again, these will be the exact same. Then we'll do 18.19 times 2 divided by 3. And you get 12.13 moles of iron 3 oxide. Again, 4 sig figs, 4 sig figs. So now I look and I get to see which one is going to be my limiting and what is my theoretical yield. So I always want to pick the smaller of the 2 numbers. So that means I can produce 6.585 moles of iron 3 oxide. And it would also mean iron would be my limiting reactant. Also, not always is the top one going to be your limiting reactant. Just for these 2 problems it happens to be. So just be aware of that. Don't always assume that first one you do is going to be your limiting. Okay, so this one's a 2-part question. So we're going to talk about limiting and excess. So what mass of cobalt chloride is formed when the reaction of 3.478 times 10 to the 23rd atoms of cobalt with 57.92 liters of chlorine gas at STP? Again, STP just means standard temperature and pressure. It's just telling you you're going to use that 22.4 that we talked about. Part 2 is, or part B, is how much of the excess reactant reacts and how much is left over. So we want to figure out how much is actually used in the problem and then how much is going to be left over. So the first thing we got to do is figure out what is our excess reactant and which one is our limiting. So I start with my first known, which is 3.478 times 10 to the 23rd atoms of cobalt. My unknown is the mass of cobalt chloride. Start with what I know. So I have 3.478 times 10 to the 23rd atoms of cobalt. That means since I'm in atoms, I need to have Avogadro's number down there on the bottom with 1 mole on top. I then need to convert from moles of known to unknown. So I'm going to have 2 moles of cobalt with 2 moles of cobalt chloride, again coming from those coefficients here. I then will switch into grams of cobalt chloride, so I need to figure that out. So I'm going to take my atomic mass of cobalt times 1, chlorine 35.45 times 3, add those up. So you get 165.13 grams. Plug that in up top, and then solve. Multiply across the top, get your answer. Multiply across the bottom, get your answer. Divide those two answers, and we get 95.40 grams of cobalt chloride. Again, anything in front of that times 10 is significant, so we need 4 sig figs for our final answer. Okay, we gotta do our other known. So we have 57.92 liters of chlorine, and we have our grams of cobalt chloride. Again, same unknown for both problems. So we start with what we know, 57.92 liters of chlorine gas. We then are going to put our 22.4 liters at the bottom over 1 mole. Switch from moles of known to moles of unknown. So I'm going to have 3 moles of chlorine on the bottom with 2 moles of cobalt chloride. And then plug in my molar mass, which I already found before. Again, this section here will be the same on both problems. So don't do extra work you don't have to. Okay, now we multiply across the top, get your answer. Multiply across the bottom, get your answer. To get your final answer of 284.7 grams of cobalt chloride. So now I have to look at these two numbers and figure out which one is going to run out first. The one that runs out first is going to be our smallest of the two. So that is going to be our 95.40 grams of cobalt chloride. So that means our cobalt is our limiting reactant. Our chlorine is our excess. So that should answer part A. So we'll be able to make 95.40 grams of cobalt chloride. And now we get to figure out how much of the excess reactant did actually get used in the reaction and how much is left over. Okay, to find how much excess reactant there is or is reacted, we have to do a third calculation to figure out the limiting reactant as the known and the excess as the unknown. So like we talked about before, our cobalt is our limiting reactant, our chlorine is our excess reactant. So we're going to start with our limiting as our known, and we're going to convert that to our excess, which is our unknown. And again, we're just using the numbers given to us in the problem because again, these are the two amounts that are being used in the reaction. So we want to figure out how much of this excess is left. So we start with our known, which is our limiting reactant. We have our unknown of liters of chloride. So we're trying to figure out how much was actually used. Start with what we know, 3.47 times 10 to the 23rd. We put our Avogadro's number on the bottom with 1 mole. I then need to convert from moles of known to unknown. So 2 moles of cobalt with 3 moles of chlorine. And then I need to put this into liters. So I'm going to end with 22.4 at the top and then have our 1 mole on the bottom. So we're going to multiply across the top, get your answer, multiply across the bottom, get your answer. Divide those two answers to get your final answer of 19.41 liters of chlorine. So that means in the reaction, we use 19.41 liters of chlorine out of that 57 we originally used. So that would be this very first part. How much excess reactant was used in the reaction? 19.41 liters. Now we need to figure out how much was left over, which is a simple calculation. All you have to do is use the amount given to you in the problem, because that's how much we had in total. Use what you just found as the amount that we used in the reaction, so 19.41. Subtract those two numbers, and we get 38.51 liters of chlorine. So that means we have 35.41 liters of chlorine left over. So that's all I have for today. I know we kind of ran through that quickly, but the main things to take away. We have 2 mass to mass or whatever type of calculation we have to do. Your knowns are given to you in the problem. So those are going to be your two numbers. Your unknown is always going to be whatever it's asking you. So what is the mass of cobalt chloride? That is your unknown. You have the same unknown for both problems. It does not change. Then you need to solve whatever number is the smallest. Again, it is not always this very first one here that you solve. Sometimes it will be the bottom one, so always do both calculations. But whatever one is the smallest, it's going to be the max amount you can make. And then whatever your known is telling you that is going to be your limiting reactant. You are going to run out of that first in the problem. Your excess is whatever made the bigger amount in the problem. So please let me know if you have any questions. I will be back Friday, and I will try and get us through this as fast as possible. Have a great rest of your day. Bye.